So which course you guys are enrolled for? Which course you guys are enrolled for? SAS and R, right? So your SAS part is done, right? So your SAS part is done. Tell me, what actually you have done in your SAS? What is SAS? What's the abbreviation of SAS? Don't tell me that. Don't tell me that. That's not the abbreviation of SAS. No, no, Rajshekhar. It's not the abbreviation of SAS. But fine. If I just ask you Java, Python, and SAS, what is that factor which is different in SAS when it gets compared with Java or Python?
It's a more of a data management tool rather than coding stuff like that. It's more
so it's meant for statistics.
So yeah.
It's meant for statistics. It's where like all the statistical algorithms are coded, pre-coded, statistical algorithms especially, and then it is meant to be used for statistics, right? Okay. So I don't have a good name or bad name. My name is Sunit, and I have been working into analytics industry for the last 4 years. I'm a certified big data developer. So I'll be taking your R classes, and I'm here with Analytics Labs as an associate consultant. So I'll be dealing with any kind of projects or external stuff that we get. But I also know a few things or two about R, so that's why I'm here. No, that's not Sumit Bansal. I'm Sunit Prasad. Okay. Okay. That's fine. That's the sad story of my life. The name sounds common, but it's not common. Excuse me, sir. Is there any problem?
Can you please
you can turn off the fan, please. Yes. Yeah, before we can finish this. So that's the sad story of my life. My name sounds common, but it is not common. People mistake me for Sumit and Sunil, but I'm Sunit with an N in it. Online guys, is there any issue with the voice? Okay. I asked you a question a few minutes ago. What is SAS? SAS, you said it's a statistical programming language. So all your statistical algorithms are pre-coded so that you can just come and use it directly, right? Also, all the processes that you have done in SAS, like importing data, transforming it, cleaning it, making it ready for analysis. Yes, those tasks. Also, some other tasks you have done till now, like merging or finding out things. Yes. So those things plus your analysis part, exploratory statistics, high-class predictive modeling, everything is ready-made available to you. You don't have to sit on the drawing board and write the algorithm. Everything is pre-coded for you. That's a statistical language. So R, like SAS, is a programming language and software environment for statistical computing and reports. Basically, it's the other like it's an alternative to SAS. I mean, like, if I can say, because you guys know SAS now, so I can say it's an alternative to SAS that you are trying to learn for the next 5 or 6 classes. So it has pre-coded libraries that implement your ETL part, basically extract, transform, and load the ETL part of the data, what you have done in SAS. Your exploratory analytics, which you will be doing in your first 2 BA classes, getting those summary statistics, central tendencies, variances, those stuff. Classical statistical tests, again, it's your BA first 2 classes where you'll be performing t-test, z-test, and other tests on your data to find out or to know about your history. So these tasks, so all these functions are pre-coded available in both SAS and R. Yes. Now, linear and non-linear modeling algorithms, again, both SAS and R will have it. Here we are learning R, so I'm just explaining you it in terms of R. Time series, yes. Classification, clustering, machine learning, which is something area of expertise of R. Machine learning is kind of a artificial intelligence technology in which you can reuse your code, but with some intelligence attached to it. Like the computer will decide the best things for you depending on your codes. The machine will try to learn what you're doing over the course of time, and it will infer the better results. So it's almost like implementing an artificial intelligence algorithm in your system. And this can be done only in R or Python maybe, not in SAS. Again, as a part of components of R, online guys, are you able to hear me? Okay. So R gives you everything what a traditional programming language gives you. Because see, if you just go to the origins of these languages, these are here since 1970s. The only thing is that SAS has become popular. SAS had become popular in late 70s, and it has been the industry leader for the last 40 years. But languages like R, S, or SPSS, IBM's SPSS, they have been there in this world since the 70s. So R started out as a language which is more closer to your traditional programming language. SAS was made to be more easier and user friendly, so the syntax looks like plain English, as if you're writing an English statement, just a statement. But R syntax looks like an actual programming language. So it gives you all the amenities like conditionals. You have done it in SAS as well. If conditions, yes. If else, you have done that in SAS. Loops, yes, you have done loops in SAS. The while loop, yes. But R gives you a lot of other loops as well for do while and other stuff. User-defined recursive functions. This is the USP of R. If I just compare it with SAS or SPSS, the most significant bit here is that you can create your own functions. In SAS, you can't do it. In SAS, you can't write your own proc. Or don't tell me that you have macros. No. Macros is just like, Tata Nano pretending to be a car. Tata Nano is not a car, right? Mm-hmm. So macros are different. Functions are different. This is the most powerful point of R, having functions. And other input and output facilities, like I can import CSV files, I can import Excel files, I can connect to a DBMS and import it to my system. And I can have a very beautiful output system, the equivalent of proc ODS. We have something called R Markdown in R. Something with which we can create reports or display our results and findings to the end user. Because at the end of the day, your client is stupid. He doesn't understand stuff. He needs to be explained in a very humane way. With all due respect, of course. No offense meant. So you have to explain them in a very clear way. So you have a very beautiful thing called ODS in SAS. I think there is no other technology in this world that can beat ODS. ODS is a very beautiful thing that has happened to this reporting world. And in R, you have something called R Markdown. So we'll learn all those eventually by the end of your 6th class or 5th class maybe. When you have started working with SAS, some of you might have used the portable one, some of you might have used the university edition one. Like whatever edition may be, like if I just go for a production level SAS software, it almost looks like I mean, like it runs in a web browser, and it almost looks like your portable edition. Like if anyone has used the portable one, like if I can show you just a second. Hang on for a minute, I'll show you that. For all those people who have not used it. So this is how your portable, this is SAS 9.0 something, but over the years SAS has not improved much on its interface. So this is how the interface looks, and it runs on a web browser on a production level scenario. Or people would be using something called SAS Enterprise Guide, which is an even more costlier thing. I mean, like costlier system. I mean, like this alone is 4.5 lakhs for a single standalone desktop. So Enterprise Guide is almost around 13 lakhs per annum. That software licensing cost. So it runs on a browser and looks like this. So R, what happens? Your R looks like somewhat this, like the crude, the native R looks like this. Just a second. So this is your R to begin with. So this is your R, and this is how you will be writing your R programs. Happy? Why is SAS more popular than R despite being so expensive? Okay, I'll tell that. But yes, this will be your place where you will be working your R. This is how you will be writing codes in R. Sounds scary, right? Okay, but this is where R begins at. The command line is the place where your R actually, the brain of R begins. Now that you have your brain, you have to give it a body and proper dressing, right? So for that, I'll be using something called a GUI, graphical user interface. So I'll be having something called RStudio to work upon. So this is my working environment. So I'll explain that, don't worry. My next slide will explain you this. So here what I want to say is, where are we? So it basically uses a command line interface, the one which you have seen, a Linux terminal or a Mac terminal or a Windows CMD. It's a command line interface. That's the starting point of R. And we have other GUIs to work upon. Fine? Okay. There are lots of GUIs, but predominantly we will be using RStudio. Yeah, here comes the best part. So when I said R gives you functions, that's the USP. No. Internally, the main part is that it's free. And the entire world likes free stuff. Yes, we all love free stuff, right? Free stuff can even win you elections in this country. Yes, it does. Yeah, it does. I say I have a political party, I'm giving you free t-shirts, I'll get at least 10-15 votes, even if they don't know who am I. So R is open source. Not just it's free to use, you can also modify the code and release your own versions of it. Yeah, you can do that. Yes. So Vishal, why is SAS more popular than R despite being so expensive? Because it is expensive. No, who doesn't like expensive stuff? Yeah, try gifting a cheap necklace to your wife. You will know that. Just kidding. On a very serious note, SAS has been so popular because of its robustness and its ease of use. And of course, the security. The security that even today, despite so much of costs, the banking domain still relies on SAS, and it's very reluctant to get into any kind of open source system. If you just happen to talk with the CEO of Amex, just drag him, bring him to your dinner, ask him if you're using SAS or R, he'll say SAS because she will say SAS because SAS is more secure. And banking, again, like I said, banking and insurance domain, they are very reluctant to get into open source systems because of security. But that's again not an issue, because if you have good IT team, you can onshore security It's well-known fact. But again, who will take that pain? Like if you're a statistics company, if you're a business organization, doing something which has nothing to do with IT, let's say, you're just a user of a product. Let's say you're running a small e-commerce store. You have a clothes store. You're running a small e-commerce store. You have a website which you have bought it. You have an e-commerce website, you have bought it, and you have outsourced your delivery to some organization. You're working for it. And you need analytics. Of course, you need analytics for that. You would definitely go for SaaS because it's easier for you to do it. Or you would definitely go for something called Tableau or Excel maybe. Because those things are easier for you. You won't hire someone to write program in R, right? Unless until you are a consultancy. A huge consultancy where you undertake projects for others, yes, and you would happily get into the coding in R, right? So that's why SaaS has an advantage over there, being simple and being easy, right? You don't have that headache. You just throw the money, get your work done. That's it. That's why it's famous. Okay, any other questions in this slide that you want to ask? Online guys? Okay. This is just a brief history of R. What's the USP of R? One is that it's free. Two is that I'm able to reuse the code reusability. I'll discuss that in detail in my upcoming part, in which I'll be talking about something called packages. All right. So there was a language called S for statistics. Yes, it is S for statistics. So that used to be a paid software developed by Bell Labs. Yeah, but if you just know a brief history of all the softwares, especially the operating system, there was a time in the 70s when the revolution of open source systems started. Like when Unix started to charge some fees, people came up with GNU, GNU. GNU for GNU is not Unix. So when that revolution started, most of the software, whether it is your day-to-day word processing software or even your operating systems or maybe some factory system software, all the software started becoming open source. So S used to be a paid software, and inspired by S, those syntaxes and all, everything were copied into a new language called R. Basically, they took the language called S and made it open source and renamed it as R. And there is no abbreviation for R except for the only explanation that it was made by Ross Ahayka and Robert Gentleman. And these two gentlemen have R in their name, so it's named as R. That's it. That's it. There's no other explanation, abbreviation for R. Seriously, I'm not joking. You can see all the smiles and giggles, but I'm not joking. Okay.
Is S transformed to R or S still exists?
S, I think it doesn't exist. S is just converted into R now. So your first version of R was released in 2000. So look at the gap here, almost like 10 years. Right? Your first version released in 2000. But one thing is, despite the 10-year gap from the time it was created to the time it was released to the public, what happens is every year you have a new release of, you have multiple releases of R actually. Like when I made this slide in October, I was using this for the December batch or so. It was 3.3.2. Now if you just look at it, it's 3.3.3. In March it was released. Yeah. So the releases are frequent. The bug fixes are frequent. So R is improving itself. R is trying its best to improve and to match up with the production level data, just like SaaS is. over the time you can understand why R is so robust, despite the fact that it requires your attention. It's like owning any kind of commercial commute bike versus owning a bullet. If you have a bullet, you have to spend most of your time and energy in taking care of it. That's what R is. By the way, how many of you own a bullet? Yeah? Online guys? How many of you have a Royal Enfield? Hello? Used it. Okay, that's great. Hardly. That's great actually.
I have.
So these bikes, they require more of your attention. Like you need to take care of it, right? The Royal Enfield guys assemble and agree with me that we have to take more care about it. So yeah, R is Indian Harley. No, Harley is US bullet. Yeah. So R is somewhat like this. You have to take care about it. It's not like no one else will do it. You have to spend the entire time and work over it. So it's fairly intensive process working with R. Yes, silence please. It's a fairly intensive process working with R. That's what I meant to say. Apart from all the BS. Okay. I'll skip this. It's just bedtime story, so you can just read it afterwards. Okay. Features of R. I'll tell you in brief. R is something what you like I said, we are into hardcore programming now. So just come out of that feeling of joy and butterflies and rainbows of SAS. It's not that. Now your hard time has begun a little bit. So R is something called object oriented. So any programmers here? Java programmers here? Used to online guys? Okay, tell me what's an object oriented system? What do you mean by an object oriented system?
Basically, reusability of code.
No.
Means classes and inheritance.
No, it's not just reusability. Can anyone tell me what are objects? No issues. Take your time. I want this question to be answered in the next Saturday class. I need a very good explanation for this. So programmers and non-programmers both, just do a small research on this. What do you mean by object-oriented system? Any system which depends on objects, that is real-life entities rather than procedures, data and functions encapsulated in a single entity called objects. Okay. I'm not convinced with these explanations. Even I have Google. I can see that there on Google. So yes, programmers, I have a task for you. The next Saturday, I want a very good explanation for it. Like if you were to explain object-oriented system to a 5-year-old kid, how would you do that? Just come up with a very good explanation. So if a 5-year-old kid is convinced, I will feel happy about it. Others will also get convinced. So next class we can see if I start my lecture on object-oriented systems, it will take 10 more hours. So I wouldn't do that. And also we don't have to know about it. We just have to know what are those few features of object-oriented system that will matter a lot to me in my learning path to R, how it will affect me. Anyways, as of today, let's all know one fact that R is object-oriented. Next class, anyways, we can look at the explanation of it because by then we would have run some codes, so we'll have clear understanding of stuff. All right? Okay. And again, this is for the programmers. Nothing to worry. This is not as complicated as what we have seen in Java. This is not as complicated as what we have seen in Java. This is much, much easier. Fine. Okay. You have one there? Okay. The second feature here is it can be easily linked with other systems. If you know, like if I make an IT project, if I make a software, it can be a desktop application or it can be a web application. Yeah, there has to be a user interface for that. Without it, it's meaningless. So the user interface has to be coded. If it is a web interface, it has to be coded in any HTML server-side language like HTML plus PHP or ASP or maybe Python or maybe VB.NET. Yes. Or if it is a desktop app, I can make it with Python or .NET. Yes? Yes or no? So it has to be. It has to have an interface. So if you're making any statistical project, if you're making any statistical system for your company or for your client, you will have an end-to-end application which will have proper input facility and it will properly show your outputs, your graphs, your tables and all. So you are basically using some non-R application for your purpose. Let's say you have used Java and created a web interface or a desktop interface. Now, the main facility with R, the main ease of use with R is that it can easily interact with other languages. The so-called objects of R can get into Java, C++, .NET, C#, any of those objects. They can interact freely. So if I take an R object, I can take other language object, these objects can easily interact with them. So data transfer can be easily possible. So that's one of the best feature of it. SAS, yes, SAS it can be done, but not directly. I have to make use of my shell or batch files or batch processing for that, which I think they might not have told you. They might have told you just the brief of it. I don't know if they have covered batch programming for you in SAS classes. But SAS uses something called batch programming if it has to interact with other systems. R, it's not required. R directly can interact with other systems easily. Fine? So that's one of the best features of R. But again, please remember, in this course, we are not touching the creation of an end-to-end app. We are not doing that. We are assuming that we are analysts and all we get is the data, how to handle, how to extract, how to transform it, and how to do any kind of actions on it. That's what is our goal. So we will be sticking to that. We won't be developing an end-to-end app. Fine? Okay. If you look at some commercial tools like, I'm not sure about Tableau desktop, but there is a version of Tableau. Tableau, you know, right? Tableau is a visualization software. Tableau can run R codes within it. There is a facility to do so. Your Excel can run R codes. You don't need VBA coding, like people coming from the visualization courses here. You have done it using VBA, right? You have done Excel VBA, dashboarding. You may not require VBA. R can be run into Excel. R can run its function inside, within Excel. Yes, even SAS can run R codes inside it. There is something called proc IML, which can be used to run R code. So R can be executed, embedded in other commercial systems as well. So if you are a user of any commercial, SPSS, I don't know, I'm not sure about it. Any SPSS users here? Okay. Okay, there has been talk that like SPSS existed much before dinosaurs came into existence. Like it's one of the oldest softwares. Yep. And it's mostly used in your academics. Like if anyone is from MSc Stats or BSc Stats background, they would have used SPSS. Yes. I don't know about it. I don't know if it can run R codes in it. But most of the commercial tools will run R codes. Yes. What happened? It will run R codes within it. R can be embedded within it. Okay. The moment which everyone was waiting for. Like for the last half an hour, I've been praising R. What are the limitations of it? Yeah. Anyone who is biased, a little bit biased towards SAS, as of now? Yeah, you can tell me. What is the best part of SAS that you have noticed?
Easy.
Easy, right? Yeah. The limitation of R is that it is difficult. Yes, I'm not kidding. Coding in R is very intensive. Time and again, I have been repeating this. And just please take it as a warning that you have to spend a little more. That 10% extra effort is needed on your part to learn R. That's needed actually. But once you are done with that, the limits are endless. Like this is sky is the limit. Yeah, there's no limit actually. It's almost like universe, ever expanding. There's no upper limit in R. The only thing is like when you're learning it, you have to spend that little effort. I mean, especially given the fact that most of you are not from the programming background. You have to give that little effort. That's all. That's all is required. But I'm not beating around the bush. Coming to the point, the limitation of R is that it consumes much of your RAM. So if I'm executing something, it will be eating up my RAM. Like I need at least 16 gigs of a system to properly run R code in it. So my laptop is 16 GB of RAM. I mean, like I have taken for two purposes. One to run Hadoop, which is again a RAM consuming software, and also I have to run R in it. So again, in a production level scenario, we used to have like I was there in an XYZ company, a name which I can't say it according to my contracts. So I have been converting SAS codes into R for them. So that's how I began my career with. Like ironically, I'm a certified SAS programmer, but I began my career with killing SAS, and I'm kind of liking it now. Like I had to convert SAS codes into R. So how it goes is that like I should have a server with 256 GB of RAM to run those processes. To run those cycles, I needed 256 GB of RAM. So you can imagine the costing per day costing of the server. So R has a scalability issue. It runs in the memory instead of files. SAS runs on your files. SAS has a virtual memory system. SAS uses something called virtual memory. So that's why every time you use your university edition, sometimes it just stops because it is using up your Google Chrome's or your browser's cache because it is creating some virtual memory over there. It crashes because your cache of your browser becomes full. Once you clear your cache and cookies, SAS will be working properly. It works on your file system, physical file system. Even when you're creating a lib name, it refers to a physical file location. It works on your physical files, but R works on your memory. Everything gets stored in your memory. You're creating any variable, you're creating any data set, everything goes into your memory. That's my scalability issue in R. So most of the machines don't support larger memories, right? I can't get a 256 gigs of RAM into a laptop. I need to have a mainframe for it. The alternative is use Hadoop, of course. Something called parallel computing. Hadoop is nothing but parallel computing, something which is known as like 2 or 3 systems working together for your process. Almost like you have seen trains. If trains don't get pulled, you add 2 more locos to it, right? That's what Hadoop is about. So our system has to go with Hadoop. Like I have to do that, or else my larger data sets cannot be handled. My real-time data sets cannot be handled. This is the limitations of R. Scalability and memory issues. But apart from that, there's no other thing which bothers me using R. If I have a decent enough 4 GB of RAM in my system, I can easily run R. At least, I mean, like, don't get scared. Like the kind of work that you will be doing from now till your last BA class requires at least 4 gigabytes of RAM for your learning purpose. But remember, in future, if you're going to any workplace, you will automatically notice that those systems will have at least 16 gigs of RAM. At least. A bare minimum 16 gigs of RAM. Yeah.
So in Hadoop, physical memory is used or virtual memory? Since we have
Hadoop is again a different system. Like it uses different systems connected together. You can call it parallel computing or cluster computing. You have cloud systems. You have a lot of other systems they're connected together in parallel, and the process is done in all the systems at the same given amount of time. It's like you're distributing a task within multiple systems. Again, it's a different story actually. It's a different track.
Or like if one process takes 10 seconds like to run
So if I'm using 5 systems, it will take 2 seconds.
yeah.
That's what it does. Okay. Manoj, there are 5 classes in R. 5 or 6. Depends. Like if it is going slow, it will be 6. 4 used to be the previous thing. Like it's not that you guys are not intelligent, but you're trying to limit it to 5. And also, second thing is because you have already done a lot of stuff in SAS. Again, I don't have to reinvent wheel along with you guys, because like you guys already know the concepts. So if I say merging, I don't have to spend 40 minutes in explaining what merging is, right? So I can just tell one function in that. So that's why our classes get cut shorter. I don't have to explain you how your if then else condition works. All I have to tell you is the syntax of an if statement. That's more than enough, right? So that's fine. All right. Before I can put you to sleep with my presentations, yes, my presentations do put people to sleep. I will exit this and let's get into our software program so that it gets a little bit interesting. Yeah? Okay. Do you need a break? We'll do one thing. We'll take a 15-minute break. Come back and start with the R Studio part. Most of you are yawning in my class. Before I proceed, I just want to ask how many of you have installed R Studio in your systems? Yes, R and R Studio both? No? Online guys, okay, I should ask, how many of you have not installed R and R Studio in your systems?
There is something installation.
It's equal. Okay, no issues. It's actually not. Like we have a phrase called like this is not a rocket science, no. So after coming here, I have I think it's not a rocket science. Looks very small. Like should say it's not SAS University Edition installation. I don't know why most of you face trouble in that. So I would say our installation is not your SAS University installation. It's very easy. So Mac and Windows, you can straight away head on to this screen here. Sorry, not this screen. This one, something called CRAN. You can head on to CRAN, and CRAN stands for Comprehensive R Archive Network. You can see it on screen. CRAN stands for Comprehensive R Archive Network. Fantastic. So in it, I would head on to download R for your respective operating systems, Mac or Windows. So mine is a Windows system, so I'll go there and I'll first download base R. So this is where I'll download my first installation of R from. The base R will be here. Download R 3.3.3 for Windows. 71 MB file is that, and it has both 64 and 32-bit installations in it. No matter what your system is, just download it. That's it. Your first step is done. And once you download it, you should be installing that. Once you have done installation, on your desktop, you can see 2 icons called R. Yes? Yeah. So the very first thing what you have to do with that is, you should select them and delete it. Yes. If you see those two icons in your desktop, just select them and delete them. That's it. End of the story. Your R is installed. Now, once your installation of R is done, you should head on to rstudio.com. Should head on to rstudio.com. I know most of you have done it, but at least like I have to cover it, so I'm covering it for that sake. So once you open your RStudio, just go to the products, select RStudio. That's it. RStudio website, products, RStudio, and just download whatever is free of cost. Yes. Now I'm not going to buy now, right? So it's download RStudio desktop, free of cost, download it. That's it. So just click on download and you see a lot of options here. Can be confusing at times, but it shouldn't be because you are a proud Windows user. Download the first link. Yes, that's it. So this is for Windows. Immediately below is for Mac. So you'll get this package file or PKG file for that. You can download it. Acha, same goes with the R installation for Mac guys. You have to first download R by selecting R for Mac. I had selected Windows first, so you have to select Mac OS 10 and download that PKG file. That's it. Now Linux, people who use Linux, they are geek enough to understand this, so I'm not wasting my time explaining that to them. They can figure it out. They're the most intelligent species on this earth. Yes, of course, I can dare say it because Windows I started using since April 2016. Before that I used to use Linux mostly. My daily system contains Linux, not Windows. Okay. Moving on, that's all about installations. Once every installation is done, you should be able to use RStudio. This is where you will be working. Any questions so far? Any person? Any question? Online guys, any questions so far? Anurag, have you understood how to install the steps? Yeah, just download the RStudio desktop. That's it. It's nothing, Anurag. Just head on to rstudio.com and just select this link here. RStudio for Windows Vista. That's it. You can read it. If not, just you can use this link. I'm also doing this facility for you. Go on. You can just use that link to download. That's it. Right? Okay. Moving on. So yes, this is my part and parcel. Use of to download. Okay. Amit, I've already explained that. Which is more interesting? Working on this? Would you like to work on this? Anyone? Just tell me, like, I'm from planet Earth. If anyone is not from the planet Earth, they can just tell me that if you're really interested in working in this. I'm not. I'm from this planet and I don't want to work on this. No matter how miserable my life is, I won't run this. I will require a proper front end to work upon, right? So this is what RStudio gives me. So first installation is the R core software, the core R software. RStudio is a third-party software which integrates your R system inside it. So RStudio will be giving you a front end, and in the back, it will be running the R which you have installed first. So if someone downloads and runs RStudio, they won't be able to run anything. It's just an interface. It's just a stupid interface. It's an inference engine. So you have to have something in the background, right?
Software is only showing me this part, not this part.
it will show. Phones in silent place. Ishan, there is not much difference between the Windows and the Linux versions, whether it is R or R Studio. If you have 3.3.3 flavor release of R, it will be the same. Yeah, it will be one and the same for everything. And also, again, R Studio is a desktop version that we have downloaded. You have also seen that there is one paid version available. So that's something which runs in your server. So it almost looks like this. So this is your RStudio server. It looks like this. Same interface, but it is running in my web browser. So maybe like in future, if you're going to any organization that implements this, just know that the desktop version that you are using will be exactly the similar one with the online or server version. There is no much difference in working of it. I just wanted you to know that. That's it. So this is how you see. There is not much difference, right? This is my desktop version that you're seeing presently, and now this is something which is running in my web browser. Everything is running the same, right? Okay. I'm just closing on this. The licensing cost for our Studio Desktop is like around $1,000 per, yeah, somewhere around $1,000. Like if you really need it, yeah, $1,000 per year. And who will pay your credit card taxes? So that's why I said 1,000. Okay. Now let's get into RStudio and understand each and every like part of it, the parts of RStudio. I think most of you have already worked in R. I can see like there are some people who have already worked in R. Yes or no? Is there anyone who has already worked with R before? Okay, okay. No issues. We'll walk through each and every component of it. Even if you have done R out of your own record, that's just may feel boring, but this is essential to know each and every component before we do any kind of advanced stuff. Okay. So first let's begin with something called console. Because every coding process begins here at console. So console is nothing but like your SAS, you have, like when you're running a code, you have your log window, right? What does log window do in SAS? Log window.
It's telling what all steps.
Status basically, right? Log window gives you the status. What does an output window give you? The results. Of course, the results, right? You're writing a code in your program editor. Once you're running it, I'm not talking about the writing part. I'm talking about the running part. Your status is being shown on the log. Your output is being shown on the output window. Console is a combination of your log and output into one single window. Console combines log and output. It shows you the results. It shows you the status. It also shows you the end results. Additionally, you can also write your codes on the console. Yes, you can write codes here. Single line of code can be written onto a console. So if I happen to write something like, x is equals to 10, what does it do? It stores 10 in some random variable called x. So it runs it and it performs some actions. You can see something appear here somewhere around the values part. Yeah. So or if you happen to print x, the answer will be shown in the console. Also the status, if I say print y is something which doesn't exist, so it will throw an error over here. So everything can be done on the console. Of course, why not? Because R happens to be a command line interface language. Yes, in its natural habitat, R is a command line interface. So that's what it's happening here. So if I say x is equals to 10, yes, I have my result. So this is what a console is doing. Console is just mimicking the graphical user interface window, right? Now, is there any questions that you need to ask? Any question online, guys? No. Okay. That's fine. Any questions, classroom guys? Anything that you want to ask? Go on, don't shut. Go on. No? Okay. So that's about the console. Now, let's briefly talk about this place here called the environment window. So we just move on to my right hand side. The first thing I can bump across is the environment window, right? So environment is a place, or global environment, which I can call it. It stores all your objects. This part here stores objects. Whatever you create. If you are importing some data, if you're just importing some CSV or Excel sheet, if you're doing any kind of activities, you are creating any function, everything goes into global environment. In other words, global environment is a container for your objects. It acts as a container for your objects. That's it.
So
Yeah.
we have anything like we have in SAS data sets, so we have like our data sets
Like SAS datasets as it?
like whatever we are importing there, output window we get it. So we will get this in console itself.
Okay. Anyways, we can see that clearly when we are importing it. But just for you to know, when you import data in SAS, it turns into a SAS 7 BDAT in a physical file system. That same thing you can see it over your window. You can just browse on, go on and browse to the libraries. If you have created libraries and storing your data set there, just double click on it, it appears on your output window, right? Just same mechanism happens over here. If I'm importing a data set, remember I have told you, there is nothing called physical system in R. R doesn't work on your physical system. It works on your memory. Memory as in your RAM. So you're importing your data, it goes into the RAM, but a reference to it will be available in the global environment. Let's say I've imported some car sales data. It appears in the global environment. Yes. And if you just happen to click on it, it will show it on the RStudio window. We will see that in detail, don't worry. In second class, we can see that. How do we import data sets and how do we work on it? So that's about your environment. What does environment do? Environment is a storage box for your objects. That's the cleanest explanation that you can give. Coming to next tab after environment, I have history. So history contains all the statements that I have executed since the beginning of time, or since my last delete. So I have around 212 statements executed till the time I had last cleared this window, and everything is getting saved here in your history tab. So just now I had executed 3 statements: x is equals to 10, print x, print y. So these things are present in your history tab. It keeps a track of all the things that you are doing. It gets saved. I mean, like, yeah, I'll tell you that. It gets saved if you are saving it. Saving of files will be our part for the last class. And see how to save those files. Like I said, we are working on memories, but sometimes you need objects to be saved in your physical file system so that you can transfer it. So in the last class, we can see how we can save our objects in your physical file system rather than just keeping them in the memory, because memory is always temporary, right? In that time, I'll explain you. But just for now, just assume that everything is getting saved. So since the beginning of time, whatever you are running, everything gets saved until unless you decide to clear it by using this broomstick over here. Yeah, Just click on it. It will clear your history entries. I would answer that later. Anurag, not now.
Uh,
Yeah, please.
is the history stored even like if I log out from the session?
It gets stored. Even if I close my session, the history remains as it is. Fine? Any other questions? Online guys, any other questions? All right. Oh, shoot. Okay. If you just come down here to my bottom right, I have something called files. Files is nothing but it is just pointing to your directories. So here it is pointing to my documents folder by default. Like even if you're using your RStudio for the first time, it points to your my documents folder. These are the items present in my documents folder. So by default it is just showing your physical file system. That's it. Plots window is something where your graphs output are getting saved or getting displayed. Like if I happen to draw a random plot, don't ask me what I'm doing it. I just draw a random plot, it gets stored in your plot window where you can just go on, zoom it, or maybe you can export it from this window as a PDF or as an image. You can do any kind of tasks from that window. Okay. Packages, something which we will be seeing today in much clear details. So I will explain that. But packages window is something where it gives you a list of all the installed packages in your system. The packages window gives you the list of installed packages in your system. So if you are first time using R, if you're a first time user of R, you might notice that this window is not totally filled up. It's very limited, like it will have only 30 entries over here. Eventually when you're using R for more and more advanced purpose, you can just keep on piling on the packages over there. Now help is something which gives you the documentation of every item, every function present in your R. It gives you a brief documentation, usage of the functions that are present in your R packages. Also, it contains a detailed guide of how to learn R. The entire R learning resource is available in your help, and this is all offline. Most of it is offline. If not entirely, but most of it is offline. You can just have an access to it even without having any connection with the internet. And yes, if you are through to this, like you can learn the entire R ecosystem without any use of any kind of a training or something. It gives you the entire information. That doesn't mean that you're running out of this class now. You will be here. Don't worry about it. Okay. Yes, Amit, I'll be explaining that in a wee while. I have something called Viewer, which gives me a list of all the multimedia elements present in my R studio. That's what Viewer is. Fine. So this is about your R studio. Now, you have installed R 3.3.3. Please pay attention to this. You have installed R 3.3.3. If you require to downgrade your system to any previous version of R, or if you notice that after a couple of months or maybe by the end of this year, a new version has come up, yes? So R Studio, what it does is, once you just close and open R Studio, online guys, are you able to hear me? Hello? Okay.
Yes.
Okay. I don't know what happens with relogins, restarts. Magically, 99.9% problems get solved in that. You know, like computer is hanging, restart. Code not working, restart. Voice not audible, relog in. Yeah. This is an old joke. Like a software engineer goes in a car with his friends, his car breaks down and it doesn't start. He just asks everyone to get out and sit again. I'm like, what's happening? So he says, I'm restarting my car. Yeah. So we all are used to these restarts. I don't know why. I don't know what kind of not blasphemy. What kind of sorcery is this? Okay. So this is about your R Studio. Uh, can I just link it with every component of SAS that we have seen? Again, console is combination of your output and log. Plus, you can also write codes on the console. Environment is equivalent to your window that you see on the left pane, like left hand side of your SAS University or portable version where you can see your libraries. So environment is almost equivalent to that. History, SAS doesn't give me any kind of history tab. No, it doesn't give. Files, yes, there is an access to your file system through the same window. Like one tab will show you libraries, the other tab will show you the files. Yes? Plots, lol. Your SAS doesn't support plots. It will give you a few histograms for namesake, but LOL, it doesn't give you any kind of graphics. You have to pay 20 lakhs for it. Like it's almost something called SAS Visual Analytics. Its license is 20 lakhs per annum. SAS is almost like going to that saloon, which is costly. Like I don't know what they do, but they charge you $1,000 for it. R is like a roadside tau. He does your work. You get your work done. Get clean shave. Get your haircut, proper haircut. Still, he charges you $10-20. That's it. That's R. Okay. Guys, are you able to hear me? Online people? Okay. Packages, I think this is something, a concept which is more unique to R. SAS doesn't have this concept because SAS, the working of SAS is very different compared to R. So I won't ridicule on this. So this is how R works. I'll explain. In fact, package is the cardiovascular system of R, the heartbeat of R. Like if packages are not there, then R is totally useless. I'll explain that because I'll take this entire class in explaining packages. Help, yes, SAS also gives you considerate amount of help. I don't know how to access that in the university edition, but if you're using the portable version, you have an entire guide for your SAS 9.1. Or even, like on a production level scenario, if someone is a partner to SAS, it gives you access to tons of videos. Yes, it does. It does give you lots of videos, lots of pages, and yes, the SAS functions are also available free of cost online. At least something is free from SAS. You can look at those functions and stuff. And even like if someone is a licensed user of SAS, they will get the entire required material, whatever is required to clear this base SAS certified exam, certified base SAS programmer exam. You'll get the entire material from SAS free of cost. Not actually free of cost, you're shelling out 4.5 lakhs per annum. So at least something you'll get out of it. But R, you have help window, where you get everything. R is basically free, help is also free. Universal Association of Free Software Lovers. So I think everything we're able to match up with SAS, whatever we have done, right? Where do we write our codes? That's a big question, right? There has to be a program editor. The console is not a place where you write code. You can write codes here, but you should not write it. There has to be a program editor, right? So by default, when you're starting your R Studio for the first time, you wouldn't get it. All you have to do is just go to File. Please pay attention. You have to go to File, New File, and click on R Script. File, New File, R Script. Or you can just note down the shortcut, Control Shift N. It should create a new file for you. So this is where you write your codes. Clear? Any questions on any of those components of RStudio? How to open this code editor window? Yes, Anurag, here is your answer. All your codes, you have to write it in this code editor window and save it. Any questions till now? Classroom guys? Online people, any questions that you want to ask? Or anything that you want to link with SAS and just want to know more about it?
The environment, does it show only the tables or what all the variables?
Okay. Environment is a place, like SAS works with tables, just the tables, but R is something different. R works on objects, and everything is an object. So if you're creating I'm creating a simple variable called X there, it gets stored in environment. If I import a data, it gets saved in environment. If I create my own function, it goes into the environment. Everything is an object and everything goes into an environment. End of the story. What is the purpose of console? Console is a place where everything is actually executed. You write a code, it's almost like writing a code in a text file. You need someone to read and execute it, right? This is what a console does. Console is the actual R. Everything else is just for our own understanding. It's for user friendliness, but the actual things takes place in the console. So you write a code on the code editor. When you source it or when you try to run it, it runs on the console. So console is a combination of your log and output window.
So like we can see the log in console. So what about the code editor? Where would be seeing the log for code editor? Like
code editor, there is no log. Log.
Where can I see the output of?
On the console. On the
itself?
console, yes. See, if you're writing a code in the code editor, so let's say I'll write that for you. Say x is equals to 20 now. Yeah, and I said print x. Yeah, simple. You're able to understand those statements, right? What I'm trying to do. So you'll do the same thing what you have done in SAS. Just select them and hit on run. That's it. The output is shown on the console. That's all. But anyways, we'll discuss more of it. Don't worry about that. This is not a one-time concept to be discussed. Now, if you are making any mistake over here, for example, if you're just writing print y on the code editor and you're trying to run that statement, so if it is an error, the status and all is displayed on the console. So console is a place, universal place where every of your result will be shown. Clear with this? All of you? Okay. One last and final thing about this concepts here, what we were discussing. You're writing a SAS program and you're saving it. What's the file extension? So when you're writing an R code and you're saving it in somewhere, like if I'm saving it in documents by default, and then I'll just call it fib batch, right? It's fib batch. So what's the extension in R? It's .r. So .sas was your SAS program extension. .r is your R codes extension. That's it. Any question with the working of RStudio? Okay. I actually got interrupted in one concept. I was just explaining you how to upgrade or downgrade your version of R. This is something we got distracted and I was not able to explain that. I'm so sorry about it. So, if you wish to use an older version of R or get to any newer version of it, so just go to Tools, Global Options, Tools, Global Options. This should open this window. It has a lot of settings in it. And in the general settings, general options, in the general options, I should select the version of R that I'm using. So by default it is 3.3.2. I can just change it. If there are other versions of R installed, it points to that and I can just select that. So I'll be using my machine's default version. That's it. So it's Tools, Global Options, General Settings, R version. I hope you guys will remember that. That's how you can change your versions. Now, anyways, like I am more accustomed to a dark screen, so I can just go to Appearance and change it. This is what I do after the class is done, because I can't work on a white environment. So usually this is how my windows look. The dark, I like this theme, but this is not much presentable on a projector. So I'll be doing that. So how to do it? Tools, Global Options, Appearance. I'll be choosing something more less, what should I choose? What was that again? Eclipse, yes. Why not Eclipse? Fine? Okay. The newer version doesn't update, so there is nothing called update the older one. Like, just keep downloading your newest versions of R. They get installed as separate installations. So I can have R 2 point something in my system. I have R 3.0, I have R 3.1, 3.2, 3.3.3. By default, RStudio will pick up the latest one. By default, it does it. It picks the latest one. But if you still want to downgrade it, you can do it from the settings. Can R be installed on AWS? Of course, yes, Rajshekhar. The recent link that I had shown is an R which was installed on AWS. So I have my URL for it. So this is running on the AWS. And don't ask me the steps for it. It's available online. You can just see there are tons of videos available online on the YouTube. You can see that. We can simply uninstall the old one if you want. Yes, Amit, you can simply uninstall the old one if you don't want it. Obviously, right. How can we access the last work done? Anurag, to access your last work, you can go to your History tab, History panel. That can show you your last done work. But if you are keeping a track of your code, if you are writing the code on this, like you have already done your SAS assignments, right? Yes or no? SAS assignments and SAS case studies, you have done it. You are writing it in a program editor and saving it as a .sas file. So if I'm doing the same assignment in R, I'll be using this program editor and saving it. And the last executed command, I'm not saying the last written code, but the last executed command will be shown on the history tab, no matter where you are executing that from. It can either come from your console window, it can either come from your code window, but your last executed command will be in the history tab. Clear? Now without much delay, let's get into the syntax rules of R. And let's get started with the coding. Fine? Okay. I'll take a just 3 minute to couple of minutes of pause. If you have just any question that pops up in your mind, just let me know. I'll just have a pause for 2 minutes. If you have any questions, please let me know. All right. Yeah. Should I increase? It's freezing. Okay. 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 For a while. You can turn on the fan for a while. All right. Before we write any code in R, let's look at some syntax rules. Let's look at some syntax rules in R so that we can just get started with the things. So here we start with the rule 0. Like I said, come out of your comfort zone of SAS. Here begins your hardcore programming. So R is case sensitive. First rule here is R is case sensitive. So in SAS, if let's say this is a SAS code, if I say print X or print Y, if I would have written it like this would be still correct in SAS, but not in R. This will give an error. R is case sensitive, and if you're not accustomed to programming, 95% of your errors will be in this case sensitivity. Yes. People who are coming from considerable amount of programming background, it's okay for them because they know, they understand. C, C++, Java, they have been case sensitive languages. But people coming from non-programming, and especially people coming from the DBMS background, the SQL guys, please note it, R is case sensitive, unlike your SAS and SQL. Second rule here is, I use a pound character. This is a comment. So pound character is used for comment, and unlike SAS, which uses something like this, yes. So you don't have nothing like this in R. I mean, this can write a multi-line comment, but that won't happen in R. You have to use pound every time. Like if you are writing a comment which is of 5 or 6 lines, you have to use pound in front of each and every line. So if you're using RStudio, automatically the incrementation of this comment goes on. Like for example, if I'm at line number 5, I'm writing a comment, I'm going to the next slide. Look at it, and it's automatically putting up the pound character, right? So every time I write a comment, I have to put a pound in front of it. Yeah? So that's how you write your comments. Clear? So what I'll do is I'll just put this as, I'll just little bit of decoration I'll be doing it. And I'll call it level 0. This will be some of the basic things in R that we'll be doing. So I'll call it level 0. Fine. Some basic level of stuff we'll be doing today, and that's it. We'll close the class today. So pound is for comments. Now, let's try to look at the INC rules. So in SAS, all the tasks that you have, hello? Online guys, are you able to hear me? So in SAS, whatever functions we have, whatever tasks we have done, let's say importing a data or just running some random piece of algorithm or code, we have used a data step, or while importing we have used out is equals to something, right? Yes or no? So what it is doing, it is creating some output objects or output instances, isn't it? So there is a particular way in which you have to name it. Every language has that. Like one of the rules in SAS is that maximum number of characters is 32, right? The name should not be more than 32 characters, right? There are certain rules in every language. So R will also have a complicated set of rules. Let's see what is that. So how do we name a particular object in R? The first rule is it can contain alphanumeric characters, of course. It can be made up of alphabets and digits, numbers. Clear? So I say var1, or I can call it my data 2. So it can be of any number of characters, uppercase, lowercase, anything. Yes? Clear with this rule? Can be alphanumeric. Now, INC stands for Identifier Naming Conventions. Identifier Naming Conventions. Identifier is nothing but your variable name. That's it. So can be alphanumeric. So I have written this var1 my data 2. Please remember one thing as a part of this is that again R is, so if I'm using my data 2 with capital M and capital D, next time if I'm using it I have to use it in the same way. Yes? Yes or no? Yes. Of course, because that is what is the meaning of case sensitivity. Agreed? Online guys, any questions on that? Or any disagreement on that? Online guys? Hello? Guys? Fine. Good. I know that there is a lag between thing, like it happens in every live broadcast, but it doesn't mean that it has 1 hour lag. Please be active. Please be reply. Please reply instantly as soon as you get it. And not just few people. Like I can see Amit or Sanat or Fanendra or Ayush or Sarita, Manoj, Sahil. Only few handful of them are active. What are the others doing? I'm really curious. I'm really curious whether you're not following the class or understanding it. Waiting for name, I have suspended you twice. Please put a proper name. Okay. All right, that's fine. If everyone is attentive, that's what I need. No. Because I know the pains and privileges of attending classes online. When I done this course in 2013, I was doing this course on Analytics Labs only, the Hadoop one, and I was attending that from Pune, live classes. And honestly, I used to sleep. After half an hour of class, I used to be snoring. And thankfully, I did not turn on my mic before that. Okay. Okay. And yes, I watch Hindi movies as well. Come on. So that's one thing. Anything can be alphanumeric, should be case sensitive. You have to remember the case sensitivity of it. Symbols, when it comes to symbols, it cannot contain any special symbol except underscore and dot. So can contain only dot and underscore, nothing apart from that. So I can call it my dot data 2. I can do that, or I can call it this dot this underscore function. If I'm creating a function like this, there are some functions which there are some inbuilt functions, something like as dot character. So dot and underscore can be used. And Java guys, please don't confuse. Dot is not an operator over here. Dot has no meaning except that it's just a part of the name.
So can we name an object or function starting with dot or underscore?
That's my third point. I'm coming there. Right?
Okay.
So it can contain dot and underscore. That's it. That's my second rule. Clear? Okay. Third rule is should not begin with a number or the special character. So if I just want to call it as dot where 1, it's wrong. It's incorrect. This is incorrect. Or if I can call it 1, 2, 3 data, again this is incorrect. Clear? Last and final thing, most of you would have been intrigued by this. Usually, like if I talk about any other programming language, usually my fourth rule should be do not use any keywords. That would be my fourth rule. I mean, like there are some words which are reserved by the language and I should not be using them. And if I were to be talking about any other language, like if this were a Python class, my fourth point would be do not use the reserved words. But in R, I would say be careful not to use the reserved or predefined keywords. Because what happens in R is, if I have a function, let's say the main logic around this is, if I have a function called mean is a function which is already present inside R. I cannot use the word mean, ideally. But what happens in R, the little bit, some irritating part in R is that I can actually use the word called mean. Yes, I can use the word mean. So mean is a function which calculates average. It calculates average. But if I say mean is equals to 100, let's say I'm doing this, it's not syntactical mistake. I can still use the word mean. If you notice in the global environment, it is creating this variable called mean. Ideally, in other languages, this thing doesn't happen. Mean being a reserved word, it should stay as a reserved word. But in R, it is not happening. Clear? Why it is so, I don't know. Why it is so random, I don't know. But this is how it is.
What about SAS?
SAS, you can't use any kind of keywords. Like there are certain keywords which are defined and you can't use it. You can't have a variable called proc. You can't say out is equals to mylibname.proc. You can't say that. You can't use certain keywords. But in R, apparently you can. This is a little bit confusing part, so I'm saying be careful to not to use reserved or predefined keywords. They say poison can also be drunk like water, but you don't have to drink it, right? So be careful. That's it. But while installing packages, you install a package name. Isn't dot a keyword there? Acha. Dot is not a keyword, Anjali. Dot is just a identifier naming object. Like I can use a dot or I can use an underscore. So they have defined the package name as install dot packages. That's it. they could have also, I mean, like they have decided to use dot. If not, they could have done something like this, uh, just like this, install packages maybe with capital I and capital P for better readability, or maybe they would have used an underscore instead of dot. That's a different scenario. What I'm talking about is this: mean happens to be a function, or sum happens to be a function. Sum calculates or adds two numbers. You can see that if I say sum 12, 34, I get an answer 46. Sum is a function which adds up two numbers, but I can still use sum as a variable name. I can say sum is equals to 100 or 1000. It gets saved as a variable name. You can see in my global environment I have sum. There's something strange, right? So if I'm about to access sum, what it should print? Should it go for the function or should it go for the variable? So it becomes a little bit erratic, right? So that's why I should be a little bit careful enough not to use the keywords. Yes? Okay. Any questions, online or classroom people so far? Okay. Those are the rules to define any kind of identifier or any object name. Fine? That's a good question. See, officially R doesn't have any list of keywords. So my official fourth point here is there are no reserved words. But because you and me, we all are friends, a friendly bit of information is that be careful. Be careful while you're using any keyword as a object name. Because see, R won't say that sum is a keyword, don't use it. It won't say that. It says, you can use it. Your wish, go on. Your funeral, you can do it.
So one question.
Yeah, please.
It mentioned dot being the preferred one as in over underscore.
It's just like every language has some style codes or style guides. So we have seen this, like most of the people who have used, they are not using underscore. That's it. I mean, like there is no hard and fast rule. There's nothing wrong using underscore. Now, I have executed multiple statements now here, and in none of the statements I have used a semicolon, right? So there is no delimiter in R. Or I can say a new line character is the delimiter. In SAS you have to use semicolon, right? In R it's not required. Just press enter key. Enter key means a new line character. So it's the default delimiter. Clear? Yes, Sanat. Good news, isn't it? You don't have to write run semicolon or quit semicolon. No, not required. But again, R is like mother of all facilities, man. If you're still accustomed to use semicolons, you can still use it. It's not a mistake. I can use mean 100 semicolon, run it, not an error. Sum 1234 semicolon. Like if you're so OCD enough to use a semicolon, you can use it.
If we put somewhere and we don't put it, it's okay, it's fine.
Pardon?
If we put semicolon somewhere and miss on somewhere, it doesn't make any difference.
No, it doesn't make any difference. So if I'm putting randomly at line number 34, it says error, unexpected semicolon. It's not that. At the end of the line,
At the
end of the line, yes. At the end of the line, you can put semicolon and just leave it. No, yes, on a very serious note, for better code readability, people have used semicolon. The reason why semicolons are there in languages is because to have a proper readability. So if you are accustomed to that, you can use the semicolons. No offense to the OCD people. Also, use semicolon to run multiple statements in a single line. For example, if you look at line number 40 here. I can say x is equals to 10. Sorry. Same time I put a semicolon. I'll say print x. So here I am writing. If I had not put a semicolon here, so this will throw an error, unexpected symbol. So if I just happen to put a semicolon here, it will run smoothly and it will print the results or execute the other statements. This is what I meant. Clear with this? Okay. So that's what. Use semicolon to write multiple commands in a single line. Now let's look at operators in brief. You have already done that in SAS, but let's look at that in very brief. What are operators? What do you mean by an operator? Yeah.
Used with specific statements and we are aware of it.
Performs an operation on greater than equal to
Oh my
operator.
Oh my God. OMG. Yeah? Really? Excellent. Slow claps. In a simple language, operators are just some random symbols or combination of words that do some action. That's it. Scare the hell out of me, man. Seriously. Yeah, symbols, some symbols which do some actions. That's it. See, listen, when you're explaining stuff, I mean, like, you can follow this thumb rule. So some symbols which are meant to do some tasks. So usually I'll be classifying operators into many categories, and I'll begin with arithmetic. I don't need any thank you. I don't need any much explanation in arithmetic operators. Like, it's just your division, multiplication and all, right? But it follows some order. We all know this. It begins with brackets. Yes, the Bodmas rule. Division, this backslash for division. Multiplication, asterisk, and I'll be just putting this in comments. Plus, minus, and this is my first precedence. I also have something called percent, modulus. What does modulus do, guys? It returns? No. It returns the remainder. A modulus operator returns the remainder. That 10 divided by 3 is? I mean, like, yeah, 10 divided by 3 is 3.3 or something. Like, what's the remainder? So 10 modulus 3 is 9. The remainder would be 1, right? So that's modulus operator. I have another thing called integer division, percent backslash percent. Percent backslash percent. It's integer division. It just gives the integer part of my division. Yes. So if I say 10 divided by 3, it is 3.33. So 10 integer division 3 is just the 3. It drops out. It simply drops out and ignores the decimal part. That's it with the arithmetic operators. Oh, okay. Not an issue. Next up, yes, any question? Okay. Okay. Next up, I have assignment operators. What is an assignment operator? It simply stores a value. It sets a value. So we have done this. X is equals to 10. It stores the value 10 into X. That's it, right? But in R, you're not going to use an equal to sign. You have to use an arrow mark. So please pay attention and look at the next statement. I want to assign 20 to Y. I would do this. Which symbol is this? Less than. Somebody said greater than. So less than hyphen, that's the arrow mark, 10. So this symbol here happens to be your assignment operator in R. Yes? I repeat. Equal to is the default assignment operator, but in R you can use an arrow mark like this. So say y equals to, let's say 20. So this is your assignment operator. Clear?
So we can assign either way.
Either way, your wish. But preferably you have to use this arrow mark. Yeah? Clear? Also, you can use something like this. Say you want to store 30 in Z, you can simply say 30. Look at the direction of arrow mark which has changed. Yes? I've changed the direction of arrow mark. You can use that as well. My wish. Right? It's the care of address for all randomness, R. So I can use it anyway, whatever I feel convenient like. So that's with the assignment operator. Next comes relational operator. Establishes a relationship. We have done the if-else statements in SAS, right? So tell me what are relational operators? Yeah, go on. Greater than, less than, greater than equal to, less than equal to, and not equal to. So this is for all the people out there who are a little bit proficient in SAS, and for all those people who are learning a programming language for the first time, and that happens to be SAS. Please don't get confused. In SAS, I had an equal to character for both assigning and checking for equalities. But in R, it is different. It is just like C, C++, or Java is. I have to use double equal to sign to check for equalities. Clear? In SAS, it is simple equal to, I guess, if I'm not wrong. Ayush percent is modulus operator. It gives me the reminder of a number divided by the other. I'm so sorry I had skipped it. Next up is logical operators. You have used these things in SAS. What are the logical operators that you have used in SAS? And, or, and not, right? So in R, the symbols for and, or, and not is and, ampersand, or the pipe symbol, and not is the exclamation mark. Ampersand represents and, pipe for or, and exclamation for not.
So we cannot use and as and.
No, it's not Java. And a single and is a bitwise operator in Java, right? Okay. Oh yes, one of the operators, I've not said it in the arithmetic one, the cap operator. I'm so sorry, I had skipped it. The cap operator, it's a number rise to the other. Power operator as. In SAS, you might have used double asterisk. Even this also works in SAS. A cap operator also works in SAS. That's all about the syntax rules. I'll keep adding to these rules if I just come across any in future, just for future reference. So let's get into the level 1 of it and let's close the class ASAP. And if you want that, I want you to please pay attention and we can finish it soon. does tilde asterisk is for this thing, like asterisk is for multiplication. Tilde, yes, tilde is something called as formula operator. You would be anyways learning about it in when you're doing this regression and stuff. You'll learn about this formula operator, not now. Let's wait for it. Will double, what does cap operator do? Okay, Rohit and Ayush, let's test it out. Cap operator is a number rise to the other. Like if I say 2 power 5, 2 power 5 is 32. So I will represent it as 2 cap 5. So my answer is 32. And Ayush, double asterisk won't work, I guess. Yeah, it works. Oh, it actually works. So double asterisk works. Same as in SAS. Like this concept is same as in SAS, right? Okay, let's get to level 1, packages. To understand packages, let's understand functions first. Can anyone tell me what is a function? Can anyone tell me what function is? No. Explain that to a 5-year-old kid. What is a function? Ah, that's worse than a PJ actually. Amit, yes. Amit is getting close to that. So let's begin with this. So functions are set of statements. Fantastic, Sarika. This is what I was expecting. Set of lines or set of commands that collectively do some task, do some random task. This is what a function is, right? And we just dig a little bit deep into it. Now coming to technical aspects, the five-year-old kid is gone. Let's come to the technical aspects now. So functions take in some inputs from the user. Inputs are called as, what are the inputs known as? What is the technical term for those inputs given to a function? Arguments, yes. Not parameters. Parameters is different. Not variables. It's called arguments. The inputs to a function is called an argument to a function. Java, right? Don't worry, even I am from a Java background. Like just accidentally switched into analytics. Don't worry. So it takes inputs from the user, perform action based on the inputs, obviously, and give the results. So it can either optionally give results, or maybe it can perform some action. Yes, it can return something, or it may or may not return something, but it will certainly perform some actions for you. So this is what a function is about, right? So I had used a function called sum. It gives me 12 and 32 added, right? Now, as I keep going on, like if I'm writing a code, I would definitely write a lot of functions for myself. Like if I can have a freedom to write functions, I will definitely write tons and tons of functions, because functions help in what? You're saying something. Functions help in? Yes. Spelling please, use a B-L-I-T-Y, right? Yeah. Okay. So if I write a set of codes and I name it, I can reuse it. That is what is the main motive of a function, right? So if I had such facility, why would I keep writing code? I would keep writing functions instead and use it, right? So given the fact that I can create my own function, I would create tons of functions. Like let's say I'm doing a task and I've created 20 different functions. Now, that was for one of the tasks. My task is done. I get a new project. I may try to reuse those functions. Let's say I've reused all the 20 functions that I've created in my previous project. Now, as a part of new project, I created 30 more functions. So, how many functions I've created till now in my first and second project combined? I have now 50. Eventually, when I grow on, I end up creating, let's say, 100 different functions over the time. Problem with this is, they're not properly organized. They're not properly placed. In my project, let's say I have certain parts like input data, cleaning data, let's say summary statistics, output. I have 4 different tasks and I have created around 110 functions for the below tasks. It's always difficult for me to keep a track of it, right? Yes or no? What if I have a facility to create containers? Create 4 containers that can hold, that represent above 4 process and club, or just place the functions in the respective zone. I repeat, I have 4 processes: inputting data, cleaning data, summary stats, and outputs. I have these 4 tasks, right? I have 110 functions that I have created as a part of this. It may be small and trivial tasks, but I have created 110 functions. What if I create like 110 functions are highly random, like accessing them all together would be a great task. Like I have to search, I have to look up, and then I can pick it up. Instead of it, I create 4 containers for the above 4 process and I put functions accordingly. If I have 10 functions for inputs, let's say I create 10 different functions for inputs. I have 40 functions for cleaning the data. I have around 45 functions for summary stats, right? How much more we are left with? 55 for 15. Sorry. For outputs. So it's better to organize it, right? Like with the plethora of functions, given the plethora of functions, like if I have to pick up one function for summary stats, I can only look at summary stats and pick up that function, right? It's more organized. Yes or no? I hope everyone will agree to this, right? Now these containers sorry, these are officially called packages. Got it? Any questions? Any question that you want to ask? Online guys, any questions that you want to ask? No, Manoj. Macro is something different. Yes, macro, again on a very serious note, macro also helps you in code reusability, but it's a different concept altogether. It's not same as a function. It's a little bit different. Of course, it is different than a function. You guys are more knowledgeable in SAS than me. You have done it, right? Okay. Now, if I have packages, and there's a small story behind it. Guys, if you have, yes, the last guy over there. Any questions? Yes, sir. You can ask questions. Okay. If you look at SAS installation, it's almost 2 gigs, 2 GB of it, right? Whether it is the official university edition or the portable edition, which is so it's 2 GB. Like the entire files, the entire APIs, everything is 2 gigabytes of it. R 70 MB. Do you really think everything gets done in those 70 MB? Most of it, yes, I would say. Most of it gets done, but not all. You have to extend. Like SAS gives you a lot of beautiful functions within those 2 GB. Keeping the hatred aside, SAS gives you very beautiful functions in those 2 GB of APIs. But not like in R, you have just the basic things to begin with. Thing with R is that you have packages. So, oh yeah, all the bedtime stories. So, packages, like I said, are a collection of functions, but to extend the features or properties of R, we need to go for external packages. So the 70 MB that you download is referred to as base R. Please make a mental note of it. The 30 MB that you are the 70 MB that you are downloading initially the initial 70 MB of a download is called base R, which contains exactly around 30 packages. Clear? And 7 essential packages are ready to be used. 7 essential packages will be almost ready for usage. Clear with this? What did I say? 70 MB that you download is called which R? Base R. It contains how many packages? Around 30 packages. And out of which 7 packages will be ready to be used. Fine. So this brings me to the very first function of this day, second function of this day. First one was being print, and to explain what a print does. But here goes the very important function for this day. That is something called session info. Session info is the function. If you look at the output till here, it shows me which version of R I'm using and all, my locale, and it says something called attached base packages. Attached base packages. So these packages, the 7 packages are already loaded for you and they're ready to be used. So all the functions that I have used, like print or maybe the session info or any function, sum, mean, everything that I have used, they come from either of these 7 packages. Clear? Any questions? Any questions?
So then how you would load the remaining 23? Okay.
Hello, Ramya. I'll tell you, wait a second, Aman. Don't worry about it. These are the first 7 packages which are by default loaded for you. Fine? Okay. So that information I can get it from session info. Also, session info will also give you information of if any third-party package has been loaded. So this is my system. I have been working on some other things. So I have this data table package, a package called data table loader, a package called Twitter loaded in my system. This is because this is I have installed and I'm working on it. So you can find additional packages being loaded. But again, if you're running this for the very first time, you won't notice these things. This will be empty. If you're using it for the very first time, this part will be empty. But now, because I have loaded some packages, that's why it is showing other attached packages. So apart from base packages, what other packages are loaded in your system? So that is what is other attached packages. Clear? So I've used something called data table, something called Twitter. So that information is being shown on my screen. Now please ignore this part. Loaded via namespace not attached. This is a little bit advanced thing which I'll just ignore it as of now. Just leave it as of now. Any questions on session info? Pardon?
Last line.
Which one? This one. Other attached packages. So base packages are something which is given by default installation of R. But if you're going for any third-party packages, other packages, and if you happen to load that, then that will be shown in this other attached packages part. I'll explain that. Don't worry. If you have not understood this don't worry about it.
So if I load any of the package which comes under that 30 till
Yes.
extended to which that is showing.
That will be showing in other attached packages. Yes, that's a very good explanation. Apart from the 7 loaded package, the remaining 23, if I happen to load, they will be shown in other attached packages part. Okay. Moving on. Again, I said base packages are very much limited. I have to go for external packages. Fine. And this I have to be, I have 2 classifications for that. So what happens is, to extend the functionalities of R, and because the fact that it is an open source software, people contribute. People create their own functions and put them into packages. And they're available for free downloads. So this is what is known as external packages. So people create some packages and that will be available for you to download. That's known as external packages. Clear? And let us see how to download one external package, how to use it. Fine? Okay.
Is there any limitation that a package contains like the number of functions?
No. There are no limitations. Now let's say getting a third-party package or getting an external package. So all the 30 packages here are defined by our core team or CRAN. External package contributed by various users. Anyone can contribute it. So these are the things which are contributed by others, basically. These are available at CRAN for free download. Fine? That's it. Now, here comes the question. How to know which package we have to download? What's the function of those packages and all? Yes? That might be the question that is popping up. And also, if I have certain packages, which is the best one? For your kind information, there are around 9,000 packages available in CRAN right now, which contains at least 100,000 functions for you. So that's the power of R. 9,000 packages is a very, very big deal. It's a very big deal actually. So it's 100 times more powerful than a tool called SAS or SPSS. Because you have the entire intelligence of hundreds of brain working together instead of 2 or 3 people sitting in a room. Right? So this is what is the power of R. So the two questions, which package should we use and which is the best? So for that, what I have done is, we have given you a list of packages. I'll be sending this PPT to you. This will contain list of packages which I would be using till the end of this course. Till the end of your BA, you will be using most of the packages which I have given you in this list. So as we move along, I will be using these external packages and you would be knowing about it. Same goes with the BA class. If you're learning about, let's say you're learning about factor analysis, apart from base package, if there are other packages available, we will be telling you that. That's how you will be knowing it. You will be knowing it by learning it. So these are the list of packages which is given to you. Firstly. Second, there is a website called Crantastic. Crantastic as in cran and fantastic. So crantastic.org. So this gives you a list of packages available in CRAN right now. You can just search for it. You can just go for packages list. So this is a list of packages available along with the author, along with the contributor. And oh, I'm sorry about the figure. I said 9,000 because that was when I was taking your Jan batch class. It's 11,567 packages available as of now in CRAN. So R is growing tremendously. And it's not that quantity over quality. Yes, there is quality. Every package that comes into CRAN has a proper QC check. It has a very good quality control. You can't have any malware or anything creeping inside CRAN.
So is this website maintained by CRAN?
No, this is a third-party website which extracts the information from CRAN. Because CRAN is a little bit boring, you see. To see that thing in CRAN, you can just head on to CRAN and I'm sorry, I have to go for CRAN. Mm-hmm. Yeah, I have a thing called contributed packages. Yes. So in it, I have to go for Windows because I'll mostly be working on Windows. And here's a list of packages that are given. So I'll be using the 3.5 flavor, the recent one. So I can see the zip files available here. So this is boring. So turn on to Crantastic. A little bit interesting and organized. You can just have a list of the packages over there. Clear? Okay. Also, if you want to find any documentation about these packages, yes, you'll also get it from Crantastic. Yeah, these are for free of cost. Yes, of course, free of cost. Now, one last thing about it, about the informations in R. There is a very beautiful website called R Bloggers. rbloggers.com. This contains all the awesome and coolest stuff that is going on in R in this world right now. Contains a list of it. So every time you search for something, let's say you're trying to search for some process in R, like let's say data manipulation, you want to search. just make sure that if this is your search term in Google, if you're just Googling for data manipulation in R, you're doing it, just make sure you're adding this so that the Google results will contain results from R bloggers. And trust me when I say this, R bloggers will give you very beautiful tutorial. No matter you are a beginner or no matter you are an expert, our bloggers will give you very excellent tutorials on every topic that you can find in R. Clear? Okay. I hope you have understood like what way you have to look at for. So your primary thing would be R bloggers. Primary and easier thing would be R bloggers. Or you can look at Crantastic for the packages. Clear? Or you have Analytics Labs. Yeah. Of course you have Analytics Lab. Of course we are there for you. Now, if I have external packages, I have to do 4 kind of tasks. 1, getting them from internet to the system. Second step, making it ready to be used. Third step, unloading it after use. And finally, deleting if not required, if no longer required. So there's 4 steps, 4 tasks to done. Getting from the internet to your system. Second, making it ready to be used. Third, unloading after use. And fourth, deleting if no longer required. So every step will have function in it. Yes? Okay, here we go. To install a package, so getting from internet is installing a package. So what is the function? Yes, install dot packages is a function to install a package. So it simply say install dot packages. Let's say I want to install a package called ggplot2. One of my most favorite packages. I have certain I constantly use 7 packages. One of them is ggplot2. The others being dplyr, reshape, and all. Plotly. One of them is ggplot2. So the install.packages within quotes. I know that the exact spelling is this ggplot2, all small letters. I'll simply put it here and I'll run it. Clear with the syntax? Online guys, any questions on the syntax in line number 139? Alrighty then, if I just run the statement, so as you can see, something will get downloaded. See, it is downloading something from the internet. That's it.
It automatically gets downloaded.
Yes. So basically what happens is, if you look at the CRAN site, so these are basically the zip files. Yes, it straight away gets downloaded. So these are basically the zip files. So if I can just look on for ggplot2 in this list. So here we go. It's a zip file basically. If I just even if I click on this, it downloads a zip file through the browser. So if I go for install.package, it will not only download the zip file, but also it will unzip it and save the contents at a particular place. Clear with this? So this is what install.package is doing. Any questions?
So, I cannot get how we are making reference to install a package. You are mentioning ggplot2.
That's it.
That's it.
That's
but
it.
How from which website does it know where it needs to pick it from?
So which website you will access Facebook from?
From Facebook, but we have got Crantastic and use.
No. Crantastic is different. Everything is CRAN. Everything is CRAN.
Okay. What if we cannot search in CRAN?
Then it will say package not found.
So then,
So if I just
want to download it from Fantastic.
Okay. So let's say if I'm just using something, some random name, what happened?
So basically, the location of the package is, is at some other website.
It cannot be. It cannot be, right?
Okay.
It cannot be. Packages are there in CRAN. If you're getting packages from any other place, it's just like winning a Nigerian lottery of 10 crores. So everything is CRAN. So if I say if you're writing a wrong name, then it will say package random name is not available because it's not there in CRAN. That's it.
If I want to use it from Fantastic, any of those packages.
So that's what I showed you, right? Just head on to Crantastic, cranrproject.org, bin, Windows, contrib, and just click on any of those downloads. It will download a zip file. That's it. How do we know what's there in a package? That's a very good question. I'll tell you in a wee while. Just wait. Any questions in installations? No. See, CRAN is the official site for once and for all. CRAN is the official site. Crantastic is a third-party site. So, which one you will prefer? Of course, CRAN, right? So that's the official site which I'll go for, right? Next, see, the thing with installing a package is that it is one time. So once you install, until you delete it, it still stays in your system, right? It still stays in your system till you delete it. So it's a one-time process. So what I recommend is never use an install.package this kind of statement within your code window. They should not be used within your code window because you don't have to install package each and every time, right? And if you're implementing certain things over a system of or a network of computers, you have to make sure that every system will have the same packages which the developer had, or the packages used in a particular program. Those packages should be installed in each and every system in which the program is running. Of course, right? Yes or no? So installation is one time. You can just head on to the packages tab here and click on install. This is what is advisable actually. So by this, not only that you know the spellings of it, but also you can install multiple packages at a single go. So I went for ggplot. I'll go for another package called dplyr something, some random package which dplyr is not a random package. This is one of my favorite packages. So I'll just keep on going it like I said. I'll give you a list of packages per se. So let's say I have given you these packages list, and you decide to install all the packages at a go. You can just click on that link and you can just type your things over there. Like let's say I have something called stringer. I'll just type the name here. String R. Give a space. Type some other package. SQLDF. Yes, this is also one of the suggested package. Here we go. SQLDF. Yeah. So anyways, I'll be giving you out this list and a brief description. Fine. So this will help you to install multiple packages at a single go. So how do we access it? Packages tab, install package. Clear? Any questions online, guys? Okay, good question. So there is a small bit of difference. This function we will be learning in tomorrow's class. So you cannot write it something like this. Okay, I'll just deal with it afterwards. So you can't write this. This is an incorrect statement. Instead, you have to use something called combine. You have to put this list of names within a combine function and do it. Don't worry about it. Tomorrow we'll see this combine function, vectors and other stuff. We'll talk about combine functions. So even if you're installing a package from this install tab and you're just typing in the names, like I have said SQLDF for instance, I'll give a space and write dplyr for instance, right? So I'll click on install. Please look at the console. Please look at the changes that will happen on the console. So please look at the statement that console has generated. Isn't it using the C function? Yes? So don't worry, C function we'll discuss tomorrow, but just for your thumb rule reference, a combination of certain objects can be represented using C function. Okay. Now, once and last thing, offline installation. I would recommend not to go for it. I would sincerely request you not to do that, because again, it's almost like winning your Nigerian lottery. You guys know what a Nigerian lottery is, right? Yeah, right? Yes or no? So, it's not trusted. So if I happen to give you a zip file and ask you to install it, it's not that much trusted. So please don't do it. So, but still, if somebody gives you a zip file of a package, all you have to do is you have to say install.packages. So instead of using the package name within the quotes, do one thing. Shut up. Yeah. So within quotes, just write in the file name. So let's say in my downloads, so I think I've downloaded it somewhere. Yeah, here we go. So it's in the documents. Okay, no issues. So I have this link to the zip file, right? Don't ask me how did this path come up. So this is how you use the offline installation. You have a zip file, you have to run install.package, and instead of writing the package name, you have to point out the file name.
Just like importing files.
Kind of. So Amit, is this clear? Why not to use an editor? Because see, installation is one-time process. Once I'm installing it, it's done. Now, in an editor, you have done. You will be writing your entire code. You'll be writing your entire source code, and you don't want that installation statement to be running every time you run your code, right? It should not happen, right? So that's why I don't suggest you to write this install statement within your code window. Just write it on the console, install it, then task is done. End of the day, that's it, right? Now, one and final trick. Let's say you're working in your office and there is a person who has downloaded all the packages. Yes? So, because that is within your office, you can trust that person. So, bribe him, give him some donuts or something, and access their My Documents folder. And in their My Documents folder, you will be having a folder called R. So if you happen to run R in your system, in your documents folder, you will definitely find this folder called R. And this is confirmed. Like there is no denying the fact. So a person who has downloaded all the packages in your office, like I said, bribe him, give him pizzas, give him donuts, and take this R folder, which will have a folder called Win Library 3.3 and stuff. just copy this R folder and copy it in your, paste it in your My Documents folder. Let's say you're taking this from my system here. Just compress and take it into your system and put it in your My Documents folder. What will happen is all the packages which are present in my system will get automatically copied into your system. All the packages will get copied. So this is also a kind of your offline installation, right? And thing is, it requires some bribery. Okay. Second thing, how many of you have actually seen the language C, whether it is in your school or college? Most of you have done it, right? Most of you. If I'm not wrong. You would have something called hash include. So what happens is, despite the fact that every language gives you packages, none of them are ready to be used. Like let's say in R, you have only 7 packages by default loaded for use. In Java, it is 0. In C, it is 0. No packages readily available for you to use. You have to load it first. There is a process which goes on. You have to load a package. So in R, loading is done using a function called library. It is equivalent to your import statement. It is equivalent to your hash include. So I'll have to use library statement to load a package which I have installed. So I have ggplot2 package installed, but I cannot use any functions from ggplot2 until unless I load it. And how do I load it? I'll say library ggplot2. That's it. So that will be loaded into my system. Ignore the warnings. This is specific to my system. So using library, the functions present in ggplot2 will be ready to be used. Got it? Any questions?
What are the library? Is it installed or loaded? Only installed. ACP tab.
This is the user library.
Which one?
Packages.
Which one? The packages tab.
Yeah.
So the list, the packages that you are seeing here are already installed in my system. Not loaded. Not loaded. Yes. So these are the packages which are installed in my system. Fine? Acha. Yeah guys, library is used to load a package. Loading means getting those functions ready to be used from that package. Clear?
We have to load again and again.
Yes. Yes. I don't take bribes, Sanat. Just kidding. I'm anyways ready for pizzas. See, installation is one-time process, but load is session specific. Every time you run a program, you have to load a package. That's mandatory. And this should be included in your code file. So at the beginning of your code file, make sure that you are writing your library statements, or else you are doomed. Because you can't use those statements, right? Clear? Also, I have another function called require, which will also do the same thing. This will also load a package. That's it. There's no difference in library and require. Both do the same thing. If you like the letter L, use library. If you like R, use require. That's it. There's no difference in those packages. I can either say require package name or library package name. That's it. Now, let's say I'm just loading ggplot2 package. What happens is, in the GUI, if you just scroll down till the ggplot2 appears, ggplot2. So once you load a package, you can see a tick mark here. Clear? Once a package is loaded, you can have a tick mark. It will not give an error if you re-download. It's not an error. It's just that like your original version will be replaced by the newer one or by the fresh install. That's it. Now, unloading after use. Unloading means the opposite of require. You have a package ready to be used. After you're done with the usage, you can just detach it. Now, unloading is implicit. Once you close the session, packages will automatically get unloaded. But still, if you want to do it explicitly, if you want to write a function for that, I have a function called detach package. Detach. Please look at the syntax. It's a little bit confusing. So detach, within quotes, I should mention package, the keyword package, followed by colon, and this followed by package name. So this is the syntax of detach. So how do I detach this package called ggplot2? Please tell me. Detach, within quotes, package, colon, ggplot2. That's it. Any questions in that? Classroom guys? Nothing, Ayush. There are no pros and cons. It's just random. You can either use library or you can use require, your wish. Any questions on detach? Okay. Online guys, any questions on detach, please? Okay. Last and final thing. Install.packages will install a package. How do you remove a package? Any function to remove packages? Install.packages is for installing. How do I remove packages? Uninstall.packages. So there is a function called remove.packages. That's it. Remove.packages, and within quotes mention the package name. No, I don't want to remove this package at least. This is one of the most beautiful packages. So remove.packages, package name. That's it. That packages will get removed. Or yes, sir. You're 100% correct. Look at this tiny cross mark over here. Do you? Just click on it. It will remove a package. So I just click on it. It will remove. Are you sure you wish to permanently uninstall ggplot? So that will delete a package. That's it. That's all. I hope, guys, in today's class you would have understood the main essence of R. I mean, the answer to the question, if we have a powerful tool called SAS, why do we, I am not done yet. Who asked you to pack up? So if you have a tool like SAS, why do we need R? I hope you understood why, right? And second, you have understood some of the concepts or components on how R works. R works on packages, and this will be our thing that we have to discuss daily, like how to get a package. I'm so sorry. R works on functions. So our day-to-day tasks would be knowing these functions. And one of the part of knowing functions is knowing which package it has come from. So each and every task that we do will have a function. Like each and every task you did in SAS had a proc. Each and every task you do in R will have a function. And we'll say where this function has come from. And that's how we'll know the packages. So I sincerely hope you understood how to download and install a package, how to load it, right? So tomorrow we will be seeing much deeper part about the object-oriented system. Not tomorrow, on next class, on Saturday. Clear? All right then. Have a nice Sunday.